Hello everyone. In this lecture we'll see a theorem on Cauchy's Riemann equation in the Cartesian form. Statement: the necessary conditions that the function w is equal to f of z, which can be written as u of x comma y and I times v of x comma y, may be analytic at any point z is equal to x plus iy, is that there exist four conditions for continuous first order partial derivatives, that is dou u by dou x, dou u by dou y, dou v by dou x and dou v by dou y, and satisfy the equation as the equations as dou u by dou x is equal to dou v by dou y and dou v by dou x is equal to minus dou u by dou y, and this dou u by dou x can also be written as ux is equal to v of y, and so dou u by dou x can be written as vx is equal to minus dou u by dou y can be written as uy. So these results we have to prove. So, and I can say that these are known as Cauchy's or Cauchy-Riemann that is in short CR, in short capital CR equations. So let's see the proof. Let f of z be analytical or analytic at point z is equal to x plus iy, and hence by the definition we know that the derivative, if it is analytic, we have to write it that is f dash of z is equal to, it will be limit f of z plus delta z minus f of z divided by delta z as delta z tends to 0 exist and is unique. So once it is analytic, then we can write the derivative of its. Okay, so then as we are simplifying in the form of partial, this one, a Cartesian form. So in Cartesian or in the Cartesian form, f of z is nothing but it is u of x comma y plus I times v of x comma y. Let delta z be the increment, a very small increment in z. So what we have taken, z plus delta z. So it is a small increment in z corresponding to the increments in delta x as well delta y, means increments, that is delta x delta y in x and y. So I can say that, so here we have f dash of this. If f of z is analytic, then we can write its derivative. So in this derivative we can observe here, so z takes a small increment in the form z plus delta z. Okay, f of z. So this f of z is, there is a small increment in z plus delta z divided by delta z. So delta z stands for what here? Small increment in z. So if z if delta z is taking a small increment in z, and we know that z is nothing but what here? X plus iy. So therefore, so we it will be take a similar increment in what here? Delta x and delta y as in x and y. So therefore our right hand side will become f dash of z is equal to limit as delta z tends to 0. So right hand side will become, so in place of x, so as we know that f of z is nothing but u of x comma y plus I times v of x comma y. So therefore it will become u of x plus delta x comma y plus delta y plus I times v of x plus delta x comma y plus delta y minus, so this is actually nothing but f of z plus delta z. Okay, so minus, in place of f of z we have to replace u of x comma y plus I times v of x comma y whole divided by delta z. So I will take back and I will once again I will show you why we have taken like that. So here I have taken this f dash of z is equal to, so limit of delta z tends to 0 as f of z plus delta z minus f of z divided by delta z. So this is a function of z, this is a function of z here. So what here in Cartesian form, f of z is given by u of x plus y plus I times v of x plus x comma y. So in place of z plus delta z we have to replace this with the increment in x plus delta x, y plus delta y, and x plus delta v of x plus delta x plus comma y plus delta y. So and f of z will remain this completely as it is. So therefore the Cartesian form of this f dash of z will convert it in terms of what here? Small increments in x and y respectively. So we'll continue that case. So once we get this, so now we have to rearrange for a real part and imaginary part. Okay, so how we have to rearrange? Just concentrate. So limit as delta z tends to 0. So real part means free from I. So free from I is first term of this. Okay, and if you consider here, so the first term of, so minus times the first term of this second term divided by delta z, and iv second terms of both. So therefore real part, if you consider, so u of x plus delta x comma y plus delta y minus u of x comma y divided by delta z one side. So this is plus and this is also plus, so plus I common. Okay, next what happens here, so I will multiply this limit also. So limit as delta z tends to 0, v of x plus delta x, y plus delta y, minus v of x comma y. So these things I will rearrange. I will write once again. So f dash of z is equal to limit delta z tends to 0, u of x plus delta x comma y plus delta y minus u of x comma y divided by delta z plus I times limit delta z tends to 0. It will be v of x plus delta x, y plus delta y minus v of x comma y divided by delta z. So this is f dash here. So this part you have to give as equation number 1. Now we know that z is nothing but x plus iy, which implies delta z will become delta x plus I times delta 1. So therefore, since we know that, so this delta z tends to what here? 0. If this delta z tends to 0, so either delta x will become 0 or delta y will become 0. Means we will get two following possible. Since delta z tends to 0, if we make delta z 0, either we can say that delta x will become 0 or delta y will become 0. So therefore we can have following two possibles. So we will see that two possibles in the form of cases. Case 1. So case 1, let delta y is equal to 0. So we will consider delta y is equal to 0. If you take delta y is equal to 0, then means if you put delta z is equal to 0, at that time we will take delta y 0, then we will get delta z is equal to delta x. If you put delta y is equal to 0, what we will get? Delta z is equal to delta x, this condition. So this will apply in our equation number 1. So what equation 1? You have to be careful. So equation number 1, we have to put delta y equal to 0 and replace delta z by delta x. So in this above equation number 1, so f dash of z is equal to limit. So in place of delta z, it will become delta x u into x plus delta x as it is, comma, minus y plus delta y, but delta y is what here? 0. So therefore y plus 0 is y as it is, close the bracket, minus u of x comma y as it is, divided by, so in place of delta z we have to replace delta x, plus I, limit, in place of delta z tends to 0, it will become delta x tends to 0. So v of x plus delta x as it is, v of x plus delta x as it is, y plus 0 it will be, that is y, minus v of x comma y as it is, divided by delta x. So on replacing delta y equal to 0 and delta z is equal to delta x, so we got a refreshed equation number 1, means in place of delta y and delta z we got reframed equation number 1. So we'll rearrange these all things now. So this part, by the definition of, so this is the first limit and second limit. So these limits are nothing but basic definitions of partial derivative of u and v with respect to what here, x. So therefore I can mention here these limits so these limits means these two limits forms the basic definition are the partial derivatives of u and v. So this is a partial derivative with respect of u function u with respect to x, and this is a partial derivative of a function v with respect to x. So therefore we can write it as f dash of z is equal to the first term what we have, this complete first term we can write it as, means this completely the first term we can write it as dou u by dou x plus as it is I as it is, and the second term what we have, so that is nothing but v with respect to x, that is dou v by dou x. And we'll give this as equation number 2. So this is we got from the case 1. So case 1 what we have taken, so let delta y equal to 0. Now in case 2 we'll take delta x is equal to 0 in this above expression. So case number 2, let delta x is equal to 0. If delta x is equal to 0, what happens here? If you put delta x is equal to 0, we'll get delta z is equal to I times delta y. So we get delta z is equal to I times delta y. So in the above equation number 1, we will replace delta x is equal to 0 and delta z is equal to I times delta y. So equation 1 becomes what here? So what is our equation number 1? So we have to go back and we have to replace delta y by what here? Delta x 0, delta y, instead of delta y we have to replace delta z we have to replace what here? I times delta y. So let's see what happens. So on replacing in equation number 1, f dash of z will become limit delta z, instead of delta z, so I will be 0, so delta z will be replaced by delta y here. So you have to write delta y for the limit delta y tends to 0. Then limit, so u of x plus delta x, so u of only x because delta x is 0, so you refer equation number 1, x plus u, it is u of x plus delta y, delta x is 0, so therefore x comma y plus delta y as it is minus u of x comma y as it is divided by delta z will be replaced by I times delta y plus second term I times limit delta z tends to 0 means delta y tends to 0, again v of x plus 0, that is x plus delta x is 0 means x plus 0, that is x comma y plus delta z as it is minus v of x comma y divided by I times, so this is I times delta y. Now you can see here we have 1 upon I and here I, so this I cancels and we have, but this 1 upon I is nothing but what here you have to consider 1 upon I is equal to one upon I square on squaring, which is nothing but on simplification you will get minus I, because 1 upon I is nothing but on squaring it will become 1 upon, because we need to get the value of this 1 upon I, we cannot write anything. So to make a result, so squaring on both sides or rationalizing I on both, or you can make it like that, or else sorry, this is on rationalizing, you take better. So on rationalizing, means divide and multiply I, so it will become I upon I square. So I square is nothing but what here, minus, so I upon minus 1 will become minus I. So this result we will use for the first term. So therefore it will become, and this is a definition of what here, again partial derivative of u and v in term with respect to y. So therefore the above situation will become f dash of z is equal to, so 1 upon I will be minus sign minus I, then this completely, this first term will become what here, dou u upon dou y, plus here I cancels, so limit of v x comma y plus delta z minus v of x comma y divided by delta y, as delta y tends to 0 will become dou v upon dou y. So this expression will call as equation number 3. So we have two results, result number 2 and result number 3, and on equating, so left hand side of 2 and 3 are same, so we'll go for what here, equating 2 and 3 means right hand side of 2 is equal to right hand side of 3, and we'll go for the result here. So we'll see the results, because left hand side of 2 and 3 are same, so we'll on equating 2 and 3 we'll get, so on equating 2 and 3, so left hand side of 2, right hand side of 2, it is dou u by dou x plus I times dou v by dou x, and right hand side of 3 will be, so right hand side of 3 will go back there, that is minus I dou u by dou y plus dou v by dou y. So we'll take this right hand side, I times, so it is minus I times dou u by dou y plus dou v by dou y. So right hand side of 2, right hand side of 3. So on simplification, so I will rearrange dou u by dou x plus I times dou v by dou x is equal to, so will minus sign is there, I will shift right, so dou v by dou y will write, so minus I times dou u by dou y. So on equating, on this is real imaginary, because imaginary means I is there, so I is there, so on equating real and imaginary part, so real part is dou u by dou x, dou v by dou y, dou u by dou x is equal to dou v by dou y, and imaginary part, that is, so this real part I have equated, so dou u by dou x, dou v by dou y, on imaginary part equating, so leaving I, so you should not take I, so just coefficient of I is dou v by dou x, and right hand side coefficient of I is minus times dou u by dou y. So this is an expression for CR equation in Cartesian form, or this can be written as ux is equal to vy, and this is vx is equal to minus uy. So this is a CR equation in terms of what here, this is a necessary condition. So CR equation, that is Cauchy's Riemann equation in Cartesian form Cartesian form for the function f of z is equal to u plus I. So in this way we need to prove the proof for this CR equation or Cauchy's Riemann equation in terms of Cartesian form. Hence the proof here.